In this session, we're going to talk about linear momentum. So what are some of the basics that you're supposed to understand as far as this topic is concerned? You must understand that momentum itself refers to mass in motion. Now, if momentum is mass in motion, you know that mass, we just represent it as m, and motion, we are referring to velocity. Therefore, momentum, which is denoted by a rho, or what we call rho, which is a Greek letter, it looks like a P. Therefore, your momentum in this case is going to be your mass multiplied by your velocity. And you know that your mass is measured in kg, okay? Your velocity, you know that it's measured in meters per second. Now that we've got this, what will be the units now for momentum? Therefore, the units for momentum is going to be kg meters per second. These will be the units for momentum. Now, other literature, meters per second, they might describe it as ms to the power -1. It is still the same. So that is about momentum, mass in motion. Now, let's solve maybe an example. Let's say an object has a mass of, let's say the mass of this object, let's say it's 10 kg. And let's say it's moving at a velocity of, let's say 4 meters per second. Then we are told to ask, or we're asked to find the momentum. So the momentum in this case is going to be mass multiplied by our velocity. Now, our mass is 10 kg multiplied by our velocity, which is 4 meters per second. Therefore, we're going to have 40 kg meters per second. So this is what we are going to find. Let's solve another example. Let's say a bullet of 1.5. Let's say a bullet of 1.5, let me say grams. Let's say it is shot from a gun at a velocity of, let's say the velocity of this, bullet is 10 meters per second. Let's say it's shot in 4 seconds. So what would be our momentum? And 2, what would be the average force? So to find us the momentum, what are we going to do? You know that the change in momentum is just equals to the mass times the change in velocity. Now the mass in this case, we're saying it is 1.5 grams. So we have to convert our 1.5 grams to kg. Okay, so 1.5 grams, and you know that the conversion unit is just 1,000. So I'm going to divide by 1,000 to convert it to kgs, multiplied by the change in velocity. Now the change in velocity in this case, it was 10 minus 0. Okay, so in this case 1.5 multiplied by 10, or first we divide 1.5 divided by 1,000, it's giving me 0.0015. Then this multiplied by a 10. Now, what I have multiplied by 10, I'm going to have 0.015. This will be kg meters per second. Now that we found the momentum, how are we going to find the force that at which this gun was fired at? So in this case, it will be a bit hard for us to find the force. We'll need other, other relationships in terms of momentum and other, quantities. Now, there's an aspect of what we call impulse. Now, impulse in this case, it is the change in momentum. So we are going to talk about what we call the impulse momentum theory. Now, what does the impulse momentum theory state? It states it all stems from Newton's second law of motion. So, from Newton's second law of motion, you know that the net force is just equals to your mass multiplied by your acceleration. Now, we are saying the net force. Please don't mistake it to applied force. Applied force is different from the net force, okay? The net force is a summation of all the forces that you get after you've considered, you know, all the forces. So the summation of all the forces that are acting on the object, that is the net force. So this is equals to, you know, F net, okay? So that is it. Now, to continue on this aspect, we are saying the summation of all the forces should be equals to ma. Now, if you remember from your acceleration, we used to say that acceleration is equals to the change in velocity over time. Now, if and acceleration, the change in velocity, you are going to, you know, subtract final velocity minus initial velocity over time. This was a formula that we had, okay? Now, if the summation of all the forces is equals to mass times acceleration, now what if we replace acceleration with our v over t? Okay, because in the previous question I included an aspect of time, so I'm going to have mass multiplied by now the change in velocity over time. So I've just replaced this with, you know, where acceleration was. Now that I've got this, what am I now going to have? We're saying this is, you know, our force. Now that we got this, let me cross multiply. Now if I cross multiply, I'm going to have force multiplied by the change in time is equals to mass multiplied by the change in velocity. Now that I've got this, this that I have on my right, on my left hand side, is what we are calling as impulse. This, what we are having on the other hand, can you guess? We said mass times the change in velocity, or mass in motion, we said it's momentum. So now we're able to see that there is a relationship between impulse and momentum. Impulse being the force multiplied by your time. You know, momentum being the mass multiplied by the velocity. So basically this is what we call the impulse momentum theory. Let's solve an example. Let's say you have an object. Let's say this is our object, not really drawn to scale. If this is our object, let's say this object, the force that was acting on this object was 20 newtons in that direction. Then maybe the time of impact, let me say it was about, let's say your time was about 10, you know, seconds. Then let's say this object has a mass of 10 kg. So number one, how are we going to find the impulse? Number two, how are we going to find the change in momentum? Then C, we can say how are we going to find the final velocity if, let's say, our initial is equals to 0 meters per second. And how can we find, let's say, our v final, the final velocity, let's say if your initial velocity is equals to 15 meters per second. So how can we solve such a question? So first and foremost, how are we going to find our momentum, our impulse actually? So impulse, we said, is just the force times the change in time. Now in this case, the force we've been given that it's 20 newtons multiplied by the change in time, we just have 10 seconds. Okay, therefore when we multiply the two, we're going to have 200 newton second. Okay, so those are the units for, you know, impulse. Now how are we going to solve our B? B, we are finding the change in momentum. So how are we going to find the change in momentum? Actually, there is nothing much to solve because one, we've not been given the velocity and it would be hard for us to find the velocity. But what do we know? All we know is that the change in moment impulse is equals to the change in momentum. Now we've already found our impulse. Our impulse, we found that it is 200 Newton second, which is equal to the change in momentum. Therefore, our answer for B is also going to be 200 because they are the same with the momentum. However, the units are just going to be different. You know that momentum is measured in kg meters per second. So that's how we are going to solve our B. Okay, what about C? How can we solve, C? So again, we're going to say our impulse is equals to the change in momentum. Now, impulse is equals to, you know that the change in momentum is mass times the change in velocity. Now, we've been given 200 Newton second. This is equals to, now the mass of this object, we've been given that it is 10 kg. We are multiplying by the change in velocity, which is the velocity that we are finding. So if I divide by 10 on both sides, I'm going to have the change in velocity to be equals to 200 divided by a 10. That will just give me a 20 meters per second. Now, if this is the change in velocity, therefore the final velocity, what are we going to have if this is a change in velocity? Okay, allow me to rub here. If the change in velocity is 20, now you know that the change in velocity is equals to your final velocity minus your initial velocity. Now we found that the change in velocity is equals to 20 meters per second is equals to v minus u. You know that if, let's say, this object started from rest, so let's say our u will be 0 in this case. Therefore, our v will just be equals to 20 meters per second. That is the v final when it is at u is equals to 0. Okay, what if now we say u now is equals to a 15? What will be the change in velocity? So how are we going to have, we're going to have v is equals to 20. When I take the negative 15 to the other side, it's going to become a positive. Therefore, I'm going to have positive 15. So therefore, my final velocity will be 20 plus a 15. That just gives me a 35 meters per second. So that's how we're going to solve this question. Okay. Now, we're about to talk about a very important concept that you are not supposed to forget. Okay, the conservation of momentum. Okay, so what are you supposed to understand about the conservation? The conservation. What have I written? Okay, it's the conservation of momentum. So what are we talking about here? Like we've been talking about, conservation of matter, energy. That is also the same way with the conservation of momentum. Now, like any other energy, you know that momentum cannot be made or created, but it can only be converted from one form to another. So what do we mean? If you get maybe, let's say, two tracks, this one is going in this direction, it's going in that direction, and it hits on the other one, which is also maybe on the other side, and let's say they are moving in the same direction. Therefore, what are we going to have as a final momentum? If let's say this is P, this is Q, therefore my final momentum, I'm going to have P plus Q. They are going to be moving in this direction. So that is the basic principle about momentum. Now let's solve an example to put this into context. We've got let's say those people who like maybe break bricks using their hands. Let's say you have a 20, let's say this is a, let's assume this is a 20 kg block. Then this person hits it. When he hits it with his hand, it breaks. Okay, it breaks into two. Let's say this is a piece B, this is a piece C. Okay, now let's say this piece goes in this direction, the other one goes in that direction, if it is hit probably as close to the middle. Now let's say this one is 10 kg, so let's call this one as mass 1. Then let's call this one, okay, we can call this one as M1 and this one as M2. Now that we've got this, these objects, they are going to have momentum. Okay, they have mass and they are going to change motion because they've been hit. So that is momentum. Now let's say initially this was the block, nothing happened to it. Now after being hit, let's say this was the momentum final. Okay, so now one thing that you should understand about the conservation of momentum is that your initial momentum should be equals to your final momentum. So let's say I have P initial, so P initial just be equals to P final, like that. Now our P final, we've said, our P initial, we've said it is mass multiplied by our velocity. Therefore our final, let me say after the two masses have been hit, so it means we're going to have mv plus mv, because we got two bodies. This one we said is m, we said this mass 1, this one we said this mass 2. Okay, then let's say this one is the velocity for the first one, this is the velocity for the second one. And let's put figures. We already have figures, so let's say we now solve this question. So how are we going to solve this question? So allow me to rub on this part. So we have this equation, mv is equals to m1 v1 plus m2 v2. Okay, now we know that the mass is 20 kg, which we have multiplied by the velocity. Now initially this object was at rest, nothing was happening, so the velocity here it just be 0. Then after being hit, we don't have the mass. We don't know the mass for this one, but let's say the velocity for this object okay, let's say we're finding the velocity for this object. Okay, let's say we're finding the velocity for that object. And let's say this object, this other object, it has the velocity of, let's say, 40 meters per second. So how are we going to find the mass for the first one? We had a 20 kg block, it has been hit into two, and the other part we know that it's a 10 kg. So what are we going to have on the other side? Okay, let's assume not really like 10 kg, but anyway 10 kg like that. Let's say it was cut in half. Okay, it was cut in half. So what are we going to have as our mass? So our mass therefore is going to be 20 kg minus 10. Okay, multiplied by the v initial, that the velocity that we don't know. Now the mass for the second one is 10 kg multiplied by the velocity, we are saying it is 40. Now when I multiply on the left hand side, I'm just going to get a 0. 20 minus a 10, that is a 10, v1, plus 10 multiplied by a 40, that is like a 400. So now what am I going to have? If I take the, let's say the 400 to the other side, I'm going to have negative 400 is equals to 10 v1. Now if I divide by 10 on both sides, I'm going to have my v1 as, you know that 0 and 0 can cancel, I'm going to have negative 40 meters per second. Okay, now you're able to see, if you choose the direction, this one to be going as positive, when it goes in this side it's negative. That's why we have a negative answer like that. So that's how you're going to solve this question. You know, let's solve another example. Let's say this is a person. Okay, let's say he's holding, you know, the cricket bat. Then someone throws a ball, or let's say that this is a ball. He just holds the ball, then he hits the ball, let's say at a velocity of, let's say 35 meters per second. And let's say the mass of this ball is about 0.2 kg. Okay, and this is the bat for hitting the ball. And let's say the time of contact between the ball and the bat, let's say it's 0.2 seconds. So now we are told now to ask, let's find the change in momentum. Let's find the, you know, the impulse, and let's say we find the average force. Okay, so what are we going to have as our momentum? You know that the change in momentum is just equals to mass times the change in velocity. Now the mass in this case is 0.2 multiplied by the change in velocity, which is 35. Okay, so what are we going to have when we multiply 0.2 multiplied by 35? I'm just getting 7 kg, you know, meters per second. Then let's say number 2, the impulse. Now we know that the impulse is just equals to the change in momentum. So if momentum is 7, even the impulse will be 7 as well. So now 7, you know that impulse measured in newtons second. So that's how we're going to solve the second one. What about the third one? How are we going to solve the third one? Okay, so just a short while, just a bit. Okay. Okay, like this. Good. So how are we going to solve the average force? Okay, so for us to find us the average force, you know that momentum or impulse is equals to, you know, force multiplied by the time. Okay, now in this case we've already found the impulse to be 7, which is equals to the force multiplied by the change in time. Now the change in time in this case we have 0.2 seconds. So it means for us to find us the force, we're going to divide by 0.2. So meaning the force, we're going to have 7 divided by 0.2, that gives me 35 Newton. So this will be our average force. So that's how you solve, you know, that kind of, you know, an equation. Now there's an aspect of what we call elastic and inelastic. Collisions. Now these two concepts, let's say this is a white ball that people use for playing pool. Then you're targeting to hit this other ball. Let's say this is a black ball and you want to score. Okay, so let's say this is ball A and this is ball B to represent, black. This is stationary. Okay, then this is a white ball. So you want the white ball to hit the black ball so that you score. And let's say this is the score line, or where it's supposed to go. So B goes in this direction. Then the A, after hitting the B, it goes in the other direction. Let's say that is our A. So what you should understand about this is that the momentum before impact is equals to the momentum after impact. And one thing that you should understand is that momentum is always conserved. So this, let's say this is our ball 1. Our ball 1 is going to have a mass. Well, let's call it mass 1. It's also going to have an initial velocity. Okay, the first velocity. Okay, that is momentum. It's going to have momentum. Let's say because it's moving. Let's say this is moving. B in this case is going to have a mass of its own, which I'll call M2, and it's also going to have a velocity, which I'll call it U2. And then let's say this is after being hit, there is a velocity and the mass will still be maintained. And your A will also have a certain velocity. It's going to have a certain velocity and a mass. The mass will be maintained. So what do you need to know about this? So when we're talking about inelastic, collision. Now a collision is just like coming together of two objects. Maybe they hit each other. So what I'm supposed to understand here is that momentum is always conserved. Okay, whether in elastic or elastic collision, momentum is conserved. Number 2 is that the kinetic energy in inelastic collision is not conserved. Okay, so if initially ball A had, let's say, 30 and B had like 20 kinetic energy, let's say this at 20, okay, let's say this at 30 and this at let's say 20 kinetic energy. So the final for this one can be, the final after impact, it can be, let's say, instead of having a 50, you can have a 40 as the final. So the other 10 might have been lost in other forms of energy, e.g. in the sound that is made when hitting ball 2. Normally after impact, that sound is produced, and probably some potential energy. So you had 30 and 20 as the energy that you have in terms of kinetic energy, but now after impact, the kinetic energy has reduced from 50 to 40. So because of that reduction, energy has been lost. So that's the basic premise about inelastic collision. Kinetic energy is not conserved. Okay, and this is very important for us to understand. Now when we're talking about elastic collisions, what you're supposed to understand on elastic is that momentum is always conserved, like we've said, whether in inelastic or inelastic. Then in this case, your kinetic energy is conserved. So if you had 30, you are going to end with 30. Okay, so that is very important for us to understand. Now the equations for finding us these two types of collisions are different. Okay, so let's talk about what we call the conservation of momentum equation. So what is the equation here? The momentum before impact is equals to the momentum after impact. So we are going to have m1 u1, that is for A, or for the first mass. Then we are going to have m2 u2 for the second ball. Okay, then after impact you're going to have the same mass, but in this case this one is going to have a certain velocity, plus we are going to have the second ball with its mass and the velocity at which it's going to move at. So this is the conservation of momentum equation. You have to know this one by heart. Now what about the kinetic energy? Because we're talking about this object being in motion. Momentum is mass in motion. So the conservation of kinetic energy equation, you know that from the basic premise, kinetic energy is equals to half mv squared. Therefore, what would be our equation for kinetic energy? So for us to find us the kinetic energy, we're going to say half mv squared, or let's say mu squared for the first ball, or let's say the white ball. This is mass 1 and initial 1, plus for the second one it will be m2, the mass for the second ball, u2 squared. This is equals to half m 1 v1 squared for the first ball, half m 2 v2 squared for the second ball. So this is very important for us to understand. Okay, now that we've got these two equations, let's put those ones with 1 on one side and those ones with 2 on the other side. Okay, so what do I mean? I've got this one with 1 and I've got this one with 1. So I'm going to move this one to the other side. Then these ones I've got 2's. I'm going to take this other one to the other side. So let's do that. We see what we're going to have. How can I do that? Okay, allow me to rub on top. Okay, let me start with the one for momentum on top. Okay, what am I going to have? The one for momentum, if I'm going to move these ones, this one with 1 and this one with 1 to be on the same side, I'm going to take this one to the other side, and what am I going to have? I'm going to have m1 u1, okay, squared okay, what am I going to have? Okay, before I do the one for momentum, let's find this for kinetic energy. I want to come up with a certain thing here. So half m u, this is 1, this is squared, minus, when this one comes to the other side, it becomes minus. I'm taking the ones with 1's on one side. So I'm going to have half m1 v1 squared is equals to, this side I'm going to remain with half m2 v2 squared, minus half m2 u 2 squared. This is what I have. Okay, now I'm going to divide through by half, so it means I'm going to cancel all the halves because they are the same. Okay, now if I cancel all the halves, what do I now have? Allow me to write it on top. I'm remaining with m1 u 1 squared minus m1 v1 squared is equals to m2 v2 squared minus m2 u, that is v, oh yeah, that is u actually, u2 squared. This is what we have now. Now you have to remember something here. Remember the difference of two squares. Okay, so how are we going to make about the difference of two squares? Let me first factorize the mass, on either side. So allow me to rub this equation for kinetic energy. We are continuing with the equation that we just ended on. So if I make mass if I factorize mass, I'm going to have m1, so I'm going to have u1 squared minus v1 squared is equals to, on the other side, if I factorize m2, I'm going to have v2 squared minus u2 squared. Okay, so now that I've got this, I can also use the difference of two squares. Okay, now you remember, because if I've got u squared minus v squared, this is a difference of two squares. You remember, if I've got a minus b, let's say this is squared and this one is squared, this is also the same as a minus b, a plus b. Okay, so if that is a difference of two squares, I'm going to do that as well to what I have in the brackets. So what am I going to have? I'm going to have m1. This time around, I'm going to have u1 plus v1. That is the difference of two squares, u1 minus v1. Okay, we are done on the left hand side. We come to the right hand side. m2 will be equals to v2 minus u2. I'm going to have v2 plus u2. Okay, so what we have, let me call it as equation number 1. Okay, this is for the one that we're just from finding for for kinetic energy. Now what about the one for momentum, the one that is on top here? So if that is the equation, let's also put the ones on one side, the one with ones on one side, and the ones with twos on the one side. So I'm going to write it in yellow. So I'm going to have m1 u1, okay, minus m1 v1 will be equals to m2 v2 minus m2 u2. Now if I've got that, what am I now going to do? I'm also going to factorize like I factorized in the previous one. If I factorize the mass m1, I'm going to have u1 minus v1 is equals to, if I factorize m2, I'm going to have m2 v2 minus u2. Okay, I'm going to call this one as equation number 2. Okay, this one we've called it 1. Now that we've got these two equations, we're going to get the one that we just from finding for momentum. We're going to divide it into the one for the one that we just found for kinetic energy. So allow me to wrap this, so I just leave the equation for kinetic energy. Okay, so I'm going to divide by the equation that we have down. Now if I divide, let me just write this on top. So we are dividing these two equations. So I've got m1 u1 plus v1. I've got u1 minus v1 is equals to, I've got m2, I've got v2 plus u2, I've got v2 minus u2. Then we're saying we are dividing the whole expression for kinetic energy divided by the one for momentum that we're just from finding. We had found m1 u1 minus v1 is equals to m2 v2 minus u2. Okay, now see what we have. Now I can cancel those things which are dividing, so this can divide into that. The m1 and the m1 can divide. Then when I come to the other side, the m1 and the m2 and the m2 can divide. The v2 and the one for v2 also might divide. They can divide. Therefore, what am I remaining with on the left hand side? So I have u1 plus v1 is equals to u2 plus v2 plus u2. This is the equation that I don't want you to forget. Okay, you need to know. Okay, you can forget about anything that we've delivered, but you don't have to forget this equation. It is very, very important for us to consider this equation. Don't forget u1 plus v1 is equals to u2 plus v2. We're going to come back to it. Now let's solve some questions to put what we're talking about into context. What if we are told to calculate, let's say, the final velocity of two balls, assuming a perfectly so this is how they ask questions: perfectly elastic collision. So if we assume that we have a perfect elastic collision, let's say this is our first ball, okay, then this is our second ball. Let's say there's a velocity of meters per second, 5 meters per second from the first ball, which let's say is 6 kg. Let's say this other one is 2 kg and it's at rest. Okay, so let's say this, because this one is going to have a mass, let's say it's on m1, let's say this one is m2. So what is going to be our answer? Okay, or at which let's say what is going to be the the velocity for the ball, for the second ball, or for the second ball? How are we going to solve that? So because they've said elastic, momentum is conserved. So what are we going to have? We are saying m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Okay, so we're just going to replace it directly in the equation for momentum. This is how we solve elastic collision questions. Okay, let's say the initial was 5 plus 2, the final 0. Okay, for the second ball, because it was at rest. Okay, when we come to the other side, the mass for the first ball, we are saying it is it's going to be the same 6 multiplied by, what about the velocity for the second ball? Let's say we don't know, plus the mass for the second ball, we've said is 2 kg multiplied by the velocity that we don't know. Okay, what will be the final velocity of these balls after they hit each other? So 6 multiplied by 5, that is a 30, is equals to 2 multiplied by 0, that is just a 0. I'm going to come to the other side. 6 multiplied by v, I'm just going to have 6v1 plus 2v2. Now that I've got this, allow me to divide by 2 throughout, just to simplify our equation. Now if I divide by 3, I'm going to have 15 is equals to 3v1 plus v2. So let's say this one is our equation 1. Okay, so we found the momentum. So that is the equation that gives us the momentum for these two objects. Let's also find the kinetic energy. Now, when you're finding the kinetic energy, we are going to use the equation that we just found. We said U1 plus V1 is equals to U2 plus V2. So this is the equation that we have. Now, the initial velocity for the first one, it is 5, plus the V1 that we don't know, for the V1 that we don't know. Then the initial velocity for the, the second ball, let's say it's 0, plus the final velocity that we are trying to find for these two balls. Okay, so now that we have this, what are we going to do? Let's make V2 the subject of the formula. So I'm going to have, because this is just a 0, so this side of V2 is just equals to V1 plus 5. This is another equation that we have. So let's call this one equation number 2 from kinetic energy. So now your job will be to solve these, equations simultaneously. So allow me to wrap this part. Okay, so we've got 15 minus 3v1 plus v2. That is the equation that we have down. So now we're going just to substitute what we have as v2, because v2 is this from equation number 2. So what are we going to have? We're going to have 15 is equals to 3v1 plus, where there's v2, I'm going to put v1 plus 5 from equation number 2. So I'm going to now simplify. I'm going to have 15 is equals to 3v1 plus, I'm going to have v1 plus 5. Now, if I'm going to now solve and put the like terms together, I'm going to have 15. If I bring the 5 to the other side, it's going to be negative 5 is equals to 3v plus v1, that is 3v1 plus v1, I'm going to have 4v1. 15 minus 5, that is like a 10. This is equals to 4v1. Okay, for me now to find my v1, I'm going to divide by 4 on both sides. So therefore my v1 in this case is going to be 10 divided by 4. 10 divided by 4, that's just 2.5v. So in this case, v1, the velocity, the final velocity for the first ball is 2.5 meters per second. What about the final velocity for the second ball? Now we said v2 is equals to v1 plus 5. We've already found our v1, so we're saying 2.5 plus 5. And when we add 2.5 plus 5, what do we have? 2.5 plus 5, is that like 7.5 meters per second? So this is the velocity for the second ball. So that's how we solve equations on elastic collisions. Okay, now how do you solve equations on inelastic? Mostly they barely bring questions on inelastic, because they are very much simple. Okay, so momentum is conserved, but kinetic energy is not conserved. Okay, so mostly, let's say you have a block of 10 kg. Okay, so this block is moving in this direction. Let's say it's moving at 10 meters per second. Then it finds another block that is just resting. Let's say this one is 5 kg. We're saying this is at rest. Okay, so then they ask you to find what will be the final velocity after these two objects meet. So now for inelastic, what happens is that when the two objects come into contact, they are going to go in the same direction, and they are going to stick to each other. So they are going to move as a unified mass. So hence, to find the final velocity for these objects to be very simple. And you know that your P initial is equals to your P final, right? The momentum initial is equals to the momentum final. And momentum, we are saying, let's say this is M1, this is M2. Okay? Now, because these ones are moving at the same time, it would be M1 plus M2. Okay? Okay, so now that we've got this, what are we going to have? We're going to have M1 multiplied by the the initial velocity for the first one plus M2 multiplied by U2 is equals to M. Now I'm going just to put M because the mass for these ones is the same, and they are going to move with the same velocity because they are stuck together. Okay, so now we're saying the mass for the first one is 10, the initial velocity was also 10 meters per second, plus the 5 mass for the second one multiplied by the initial, the other one was at rest, so it's equals to mv. Now for m, I can put the mass because it's going to be added 10 plus 5, that will just give me a 15 v, like that. So I'm going to have 10 multiplied by 10, that is 100, then a 5 multiplied by 0, that is just a 0, is equals to 15 v. Okay, therefore my v just means that I'm dividing 15 divided by 100. When I divide 15 by 100, I'm getting 6.67 meters per second. So this will be, the final velocity for these two balls. They're going to move with that velocity after a while. Okay, so basically this is how you solve these questions on linear momentum. So whenever they stack together, just know that whenever they stick together, we're talking about inelastic. When they go in separate direction, we're talking about elastic collision. So this is how we're going to end for today. Thank you, and see you in the next session.